All right. So we will go over the quiz and stuff, and I have a ton of stuff to hand back to you, which who's going to remind me of that? All of you. That's right. Do you have a question, or are you just saying me? I will. Okay, good. Please do. Can you guys tell whether I'm tired, happy, mad, energized? You get any vibes from me indicating anything like that? I am usually pretty happy. First of all, like even if something terrible happens, like it seems kind of cliche at this point in my life. How many seconds are in a day?
It's like 2,000 something, right?
80. Wait, how many seconds are in an hour? 3,600, right?
Yeah.
And there's 24 hours. There's 86,400 seconds in a whole day. If you have an argument with your friend, somebody, you read something rude, like something just pisses you off and just ruins your day. Sorry if that's profane, not intentional. How long does it take for somebody to ruin your mood, realistically? If you have a conversation, maybe 5 seconds. They'd have to just be really blunt and to the point right away. Maybe 2 minutes, right? Like a 2-minute conversation is enough to have right in the morning, maybe an argument as you're getting out of the car to possibly ruin your day, right? Okay, again, this feels so cliche when I talk about it. If you had 86 grand in the bank, 86,400, and you had to buy something for $200, would you feel like it was a huge hit on you? Like it's not a huge issue, right? What if you have time out? I want everybody to see right here, this gentleman is a legend. He is a mentor of mine, and I respect the heck out of him. Who is he? Okay, what do you do when I announce this guy? You're going to all do what? We're going to build his ego with loud applause. Ladies and gentlemen, Mr. Jeff Dickrell. Taught here how many years?
I was a teacher here before most of your parents were born. That's probably true.
Yeah.
I taught Janae.
Yeah. Legend. Are you out of here today?
Saturday.
Okay.
That's my first day down here. So.
All right, cool.
Everybody. So he's a great guy. Tolerable teacher.
All right. All right. Cool. What's up? 35, I think. All right. So you had 86 grand in the bank, 86,400, and you get a $200 fine. Like it sucks, right? But are you like suffering? You're broke now because you just lost 200 of your $86,000? No. Like you might whine about it, but is it going to ruin your day? If you have 86,400 seconds in a day and 120 of them are ruined by some poor or crappy interaction, should you let it ruin your day? You shouldn't. It's going to. You should not let it ruin your day, though. I'm glad that I always come off as energetic and probably pretty happy because, spoiler alert, I love my life. Even my bad days are awesome days, and I'm happy to be here every single day. With that in mind, where am I going with this is a question currently. Why did I bring this up? Man, Dickrell just totally threw off my train of thought there. What were we talking about before he walked in?
Days, seconds.
Why? What happened right before that?
I don't know.
We can check. We can review the footage if we have to.
We were talking about like someone was gonna.
Oh no! It's Sorry, I didn't mean to interrupt you, but it did dawn on me just now. I am super tired today.
Oh yeah.
What time do you think I normally go to bed?
Like 8 p.m.
Okay, 6. 6. All right. I'll tell you. I hate mornings. I hate them. However, I'm much more productive in the morning. My perfect schedule would be like up till 4 or 5 and sleep till 12 or 1 is what I would like. That's like my schedule. I think days should be longer, but I can't change that. Last night, I went to bed significantly later than normal. Normally, I'm asleep by 10 p.m. because I get up at like 5 o'clock. I watch the news. I drink coffee. I walk my dogs. I do all those things. I was up until like 1:30 last night. Why? Wasn't work. I'll tell you guys, I spend a lot of time on my job, like preparing for it and stuff, but I make it a point to do all of that here. Like I come into school between 7-ish every day, so I have a lot of time before school to do stuff. Wasn't Zeke. He went to bed early. Gosh, today, you haven't noticed this, I'm going to start adding stuff. I probably mentioned it yesterday. Something started yesterday. NFL starts tonight. Oh my Rocket League new season debuted last night. Boo. I really don't hate. I just spend all my time dead. That's all that happens on Fortnite. All right, here we go. I'm stealing your homework time. Let's get rolling. What is speed? distance over time, and normally we measure it in meters per second. Now, realistically, how frequently do things in our world, you or other people, move at constant speed at the exact same rate? Like if I drive to the store and I drive 30 miles per hour, from the second I get to 30 miles per hour until I start to slow down, do I keep that speed exactly consistent? It does not work that way. Realistically, I'm probably between 25 and 45, depending on the other traffic, right? Like, if you haven't started driving yet, you'll see it's easy to speed on accident. Now, what's nice about introductory physics stuff is that as we go through this, turns out we're going to pretend like we live in our lovely, perfect mathematical universe. We don't deal with air resistance in here because it's hard to deal with. And we will deal with friction, but not initially. When we're looking at stuff, especially in these first chapters, we get to work with this lovely idea of constant speed. Now, if I asked you just in other words, rather than using the word constant, what in as few words as possible does it mean if I travel at constant speed? I'm not doing something.
No.
I'm staying equal, right? Same speed everywhere. That's what constant means. Do I ever speed up? No. Do I ever slow down? No. Okay, so no speeding up yet anyway. Here in a couple sections we'll get gravity where this will have to change, but we will not speed up or do what? Slow down. Okay. Is this really how things work in nature though? Okay, we're going to take this with a grain of salt then. If you've never heard that phrase, we're assuming it is now because we get this nice idealized version. When we deal with constant speed, it's just distance over time, which you've already defined. We've been talking about constant speed just so you guys are aware. Now, are there times when things do change speed? Yes. Does it happen suddenly, like I go directly, if I'm walking at 1 meter per second, can I go from 1 meter per second right now to being 4 meters per second? No, because to go from 1 meter per second to 4, I have to go to 2 and then 3 and all the numbers in between, right? Have you guys ever heard of a guy by the name of Zeno? Probably not. You might have. Was it from me? No. Okay, where have you heard of Zeno? Okay, so I'm not talking Dragon Ball, though. I respect it. Okay, do me a favor real quick. We're all going to stand up for just a brief moment. Stand up and stand in front of your desks or just where you're at. Sure, you got to face somewhere. You got to walk somewhere. Here's my challenge for you. Pick somewhere from where you're standing and pick an endpoint to where you want to end your little walk. A wall works really well. Towards me is fine. That'll work. Towards that wall, towards a desk. Doesn't matter to me. You should walk a different direction, though, because it's going to be weird here. Okay. Does everybody see somewhere where you at least have to take a step or more to get to? Yes. Okay, do me a favor real quick. Walk halfway there. Now you might have to estimate. Did you guys just get halfway to where you're going? Yeah. Okay, go halfway again. Where were you walking to? Did you walk halfway the distance between you and the door again?
Oh, did I have to walk halfway?
No, you just go halfway from where you are to where you're going. So like if I'm walking to those desks, I'll just show you real quick. Halfway to that desk right there is like right here-ish. Now if I want to walk halfway again, I'd say, okay, well, I'll eyeball it. It's about here, right? I went halfway between here and here now. Oh. Between here and here, can I go halfway again? If I do this, which I must, right, because I have to cover literally every spot on the floor before I can get there, how long is it going to take us to get to where we're going? Take another half step for me. Are you where you were supposed to be yet? Okay, how many more half steps do you need to go?
6.
So literally half the distance between you and I. Like check it out. This is half the distance between you and I right now, right? If I come to here and say here's half the distance between you and I do it again. I'm getting closer, right? How many more half steps, half the distances would we have to go to finally reach where we're going? Oh my infinities! Now, there's an obvious issue here. This idea is called Zeno's paradox. If you take half the distance between you and something and you close that distance every time, are you ever going to get there? Okay, do you have to cross all those distances to actually get there? But you don't have an infinity time. How do you ever get anywhere then? Why does that work? You can have a seat. Or stand there, I don't care. If you have to go infinity time to get through infinity half distances, how do you ever get anywhere? You round it off, right? There is a difference between theory and application, and it's nice to see it. Paradoxes, have you guys seen that before, a paradox? Maybe. Paradox is something like, check this out. I'm gonna give you a statement. I want you to tell me true or false, okay? This statement is false. No, I'm just asking you this. This is just a fun to think.
It says it's false.
Is it false?
If
Is it true?
No, it's false.
Why?
Oh, it's false.
If it's false, what? Wait a second. If you said it's false, then if I say that statement is false, must be
It's true.
true. But it can't be true because it says it's false. Are we ever gonna get to a solution here?
It's true that it's false.
Sure, but that makes that statement true, right?
Have you heard it?
But that's false, and all of a sudden, like, you can see there's an issue, I imagine. Now, when you look at these things, paradoxes like this happen from time to time. In reality, the half step one, do we ever have to worry about it? No, because we don't ever have to actually go through infinity, or we do all the time, we just don't recognize it. Like, it's beyond our concern. Liam, what you got?
Have you heard the Pinocchio paradox?
The what?
The Pinocchio paradox?
No.
If you ask him if he's lying, and he says yes, well, his nose will grow, or would his nose grow?
Really common riddle referenced in one of the newest episodes of Rick and Morty at one point. There's one guy tells the truth, one guy lies. Anyway, here we go. We work at constant speed, which means we don't have to accelerate or speed up or accelerate and slow down. Like, we're just going to work nice there. We don't really change speeds instantly. We have to go through infinitely many little steps to get there. We get to work with the fact that it does happen, even if it's weird when you think about the real math of it. So we need to make sure we're cool with changing speeds. Now, we're not going to get crazy into the math here. We get constant speed as we're moving, but we might change to a different speed throughout the process. Once we change, if I go from 20 miles per hour to 25 miles per hour, in our nice perfect world, it happens like that, for now at least. So, as we're looking at these, it's pretty easy to make sense of. I'm going to make a small graph that we don't need any crazy numbers here. I just need to have a context. So let's say that we have some distance that we're traveling and some speed that we're going. Okay, as I go through this, hypothetically, I'm just going to make up some crazy stuff. We're not going to do the math for it, but let's say we do this. And we'll come back up like this. We have speed and distance being graphed here at this point right here. No labels, don't care about the labels right now. Are there places where it's very clear, without talking about the mathematical language, that you'll say they're speeding up? Okay, what I want you to do is on your rough sketch, you don't have to be perfect, I don't have it perfect, wherever you think it happens, like if you think this is where we change from speeding up to slowing down or whatever, label it on your graph as point A. Label any significant changes in motion on your rough sketch that's just like this one. There's not many times that I look at your pages. I'm going to come around and look at your pages because I want to know, where do you think changes occur on your graph? It should look similar, not perfect. Does this make sense, or do we need to talk a little more about it? Okay, so let's do the first one together. Tell me when to stop when you think maybe there's a change in motion.
Stop.
Okay, why?
Speeding up.
Okay, so you're right. Am I going faster or slower from here to here? How do you know that?
Now that's the distance. A speed? Oh.
Because this is increasing, right? Okay, check this out. That's calculus, just so you know. We didn't do the math for it, but that's a concept of calculus. Everybody in here can probably understand that. So would you say that from, let's say, 0 to point A, I'm doing what again? Speeding up. We did something similar the other day with distance stuff. I want you to find other points B, C, D, E, however many you need, based on this graph to tell me where other things that might be worth mentioning change occur. So from there to there, I think I'm speeding up. And that's why I don't trust ducks. Love it. Probably shouldn't have told it, but I appreciate you guys listening. Okay, we agree, I hope, that this point is important. Now, I mentioned a second ago that this is calculus. Literally, this is calculus, just so you're aware, without the math. It's all the concept. You guys know, I think, that this section, you told me what was happening? I'm speeding up. Now, you guys have the idea of slope in your head, right? You've seen slope before. If I took the slope and I just wanted to touch right here, is this slope positive or negative? That's the calculus connection. That's it. Calculus is easy, conceptually, mathematically, Also kind of easy if you're good at algebra. Okay, you shout out when you want me to identify another important part here. So I went 0 to A. I'm cool. Here? Why?
That's when it, like, decreased the speed.
So from A to B, what was I doing?
It was decreasing.
So give me a different language for decreasing speed.
Negative.
I like that, although speed doesn't have a sign.
Slow down.
We're slowing down is literally all that's happening. Okay, sorry, whoever I meant to give credit to. Good answer. Okay, where do I stop again?
Stop.
Okay, if I asked where am I going very fastest on the entire graph, what's happening?
Going fast.
So you're giving me an interval at which point so far has my highest speed been?
C.
At point C, how can you tell?
Highest on the graph.
It's the highest value, right? My speed is just the height of this graph. Okay, from C to, I assume here's point D. What happened? It stopped. Okay, for how long?
A split second.
Do you know that?
Yeah.
Do you have any time on this right now?
No.
We have no idea how long this happened for. Okay, is this an important spot? D to E, what happened?
Sped up.
Okay, here's the big question. E to F, what happened?
Stay consistent.
So I heard nothing. Ooh, louder. I stayed at a constant speed. And I'm going to show you guys again your math ability. Even if you don't love math or you don't think you're good at math, slope is rise over run. It's like how steep a line is, right? If I were to check the slope right here between these 2 points, what would you guess it is? How much do I rise? 0. None, right? So I'm not changing my speed at all, and I can see it. All these ideas are kind of living in there. This is calculus to the extent that we're going to do calculus. Is this super hard? Is it okay if it is hard?
Yeah.
Yes. Remember, ask questions. I'm here like all the time. I want to help, but I try to do a pretty good job of not like tracking you down and making you ask me questions. Okay. I think I'm okay with where we're at. We need a couple more comments, just like vocab stuff, but I think we have everything that we need to be able to look at the assignment. So, have you guys ever seen the word, 2 vocabs? Have you ever seen the word instantaneous?
No. Maybe. No.
Instantaneous. Okay, shot in the dark. If something is instantaneous, it's going to be an adjective to describe this. What would it mean, you think? Instantly. Does that say from some really small interval of time, you think?
Yes.
Maybe. If you let infinitely small, then I'm okay with it. So we're going to talk about instantaneous speed, and it's really, really easy to define. Instantaneous speed, and it's a weird idea if we connect the calculus, but we don't have to. Literally, your speed at a single instant in time. Speed at a single instant. Now, is anybody in geometry right now? Okay. Is geometry 5th hour for? Okay, that makes sense. So speed at a single instant in time. I'm going to throw a little geometry at you. How long is a line? Sounds like a riddle. It's not.
Depends. It depends if you put like an arrow on it. Like, no.
So there's an arrow.
Oh.
If that line is what I have, how long is it?
Infinitely.
Infinitely long. Okay, I'm cool with that. It's made up of how many points?
2.
You need at least 2 to draw it. But if I zoomed in, could I put a point here and a point here and a point here and a point here and all of them all the time forever and ever?
Yes.
Infinitely many points since it's infinitely many long. Now, the last little part. How big's a point? You draw points on your pages all the time, right? You represent a point using a dot on your page. You might say, oh, it's this big. But there's really no size to it. It's just this specific location. It's not super small. It just doesn't have any size whatsoever. As you're looking at it, same thing. This isn't really just some really small amount of time. It's at that very instant in time, how fast are you happen to be traveling. Okay, I'm good with this, I believe. Cool. We have like 15 minutes with the following understanding. I'm going to give you 15 minutes to do what? Work. We can call it homework if you want to. It should just be work, though, because over the next 15 minutes, you all are going to be doing what?
Work.
If you don't, what happens?
More work.
I either give more work or no time to work on it. Or a quiz. I like all those ideas. Cool. Work, like Rihanna says. Cool. All right, so your homework. That might be too old for you guys. You recognize it, apparently. Cool. Reminder, the jokes I make are only because I find them funny. Don't have to laugh. If you roll your eyes, love it. I'm good with it. I will try to use as much brain rot as possible to make that happen. Sweet, indeed. Okay, page 44. You guys get the privilege on page 44. This is going to be homework, hopefully classwork. 2.1. Don't do it on your notes. You're going to rip it out and hand it in tomorrow. Do not do this on the back side of your notes. Do it on a separate sheet of paper.
Put this homework on the same as the other homework so I can hand it all.
Sure, as long as it's very clear on top.
Wait, and what page was
Page, I'll give you one thing, okay? Homework, right meow, page 44. You get the privilege of problems 5 through 11. Cool, cool. 15 minutes right now. If it's a mathy problem, given, find, equation, play the unit game. I know that it's tedious. Bummer, I guess. I don't know. Cool.